Okay, so this is the first part for the lecture on alcohol. Okay, so please open up the slides on alcohol. Okay, so I'm going to turn off the camera. Okay, let's look at the slide. Okay, alcohol. Alcohol is a compound with a hydrogen of alkane that has been replaced by an OH. Okay, basically alcohol is an alkane, but one of the hydrogen has been changed to an OH group. Okay. Classification of alcohol. There are three types of alcohol here, as you can see there. Primary, secondary, and also a tertiary alcohol. A primary alcohol has one R group attached to that carbon. Secondary alcohol has a 2R group attached to the carbon with an OH. And a tertiary alcohol has 3R group attached to the carbon, and that carbon has the OH group. Okay, nomenclature of alcohol. According to IUPAC system, the suffix "ol" had been used to indicate the functional group OH in alcohol. Suffix "ol" meaning that the name ends with "ol". For example, methanol for 1 carbon, ethanol for 2 carbon, methanol, ethanol, propanol, butanol, prop for 3 carbon, but for 4 carbon. Okay. Rules for naming compound with functional group suffix. Okay, this is a rule. The first rule is the longest continuous chain contain functional group that is called the parent hydrocarbon. Okay. And the second rule is the functional group suffix has the lowest number. What does it mean here? Let's look, for example, here. Okay, let's look the one on the right hand side first. If you look for this one, okay, how do we practice longest continuous chain contain functional group? Means we have, when we count the number of carbon, okay, so the functional group, we have to count for the functional group with the highest hydrocarbon. So let's begin for this one. We have here 2,4-hexanediol. Okay, so how do we get 2,4-hexanediol? We have to consider here 1, 2, 3, 4, 5, 6. So this is a 6 carbon. 6 is hexane, and at carbon number 2, 1, 2, 3, 4, at carbon number 2 and 4, there is 2 OH group. So this is called 2,4-hexanediol. For this one, let's try for this one. Okay, so this is 1, 2, 3. Okay, and in the middle there, there's O group. This is an okay. This is methoxy. Okay, and this is 1, 2, 3, 4, 4 carbon. So this one, 2, 3. This is propanol, and 3 at carbon number 3 there is methoxy group, so 3 methoxy, 1 propanol. Okay, how about this one? 1, 2, 3, 4, 5. Okay, this is quite direct. 5 is pentanol, and at carbon number 2, 1, 2, there's a 2 ethyl. So 2 ethyl, 1 pentanol. For this one, 1, 2, 3, 4, 4, so it's butanol. At carbon number 2, there's 1 OH, so 2 butanol. Okay, if 2 OH exists, suffix diol is added to the name of parent hydrocarbon. If in the case that we have 2 OH group, okay, coexist in the same compound, therefore we name it as diol. For example, here we have 1, 2, 3, 4, 5, 6. 6 is hexane, and at carbon number 2, sorry, carbon number 2 here, we have 1 OH, and at carbon number 4, we have another OH. So this is called 2, 4, 2, 4 hexane diol. Okay, 2, 4 hexane diol. If functional group and substituent exist, functional group suffix gets the lowest number. Okay, let's look at the one on the left hand side here. We have 1, 2, 3. So 1, 2, 3 is the propanol, one propanol. OH get the first carbon. And at carbon number 3, there's a bromine there. So 3 bromo, 1 propanol. Okay, this one on the middle, the compound in the middle, we have 1, 2, 3, 4. 4 is but. And at carbon number 2, there is OH group, so 2 butanol. At carbon number 4, there's a 4 chloro. There's a chlorine compound, so we call it as 4 chloro, 2 butanol. Okay, how about this one? We have 1, 2, 3, 4, 5. 5 carbon. So at carbon number 2, there's 1 OH group, so 2 pentanol. Carbon number 5, there are 2 methyl group, so 4 dimethyl, 2 pentanol. Okay, you can read that. The fifth rule. Okay, the application of this rule is that we have 1, 2, for example, the compound on the left hand side first. Let's look. So we have 1, 2, 3, 4, 5. 5 is pentanol. Okay. Now carbon number 3, 1, 2, 3. If we count it from the right, 1, 2, 3, we have 3 pentanol. And if we count it from the left, we also have 1, 2, 3 pentanol. So now, 4-chloro, how do we identify? Is it 2-chloro or 4-chloro? So in this case, because of this number 5, the rule number 5, so this is considered as 2-chloro, 3-pentanol. Okay, because if counting in either direction give the same number for the functional group suffix, the chain is numbered in the direction that gives a substituent the lowest possible number. And notice that a number is not needed to designate the position of a functional group suffix in a cyclic compound because it is assumed to be at one position. Okay, let's look at this compound in the middle. We have 1, 2, 3, 4, 5, 6, 7. 7 is heptanol. So OH is at carbon number 4, regardless if you count from the left or from the right. But this carbon, okay, it has methyl group. So because of the presence of methyl group at this carbon, this is considered as 2. So 2-methyl for heptanol. Okay, this is a cyclic compound. Cyclic compound. So cyclohexanol, okay, cyclohexanol, and that methyl group exists at carbon number 1, 2, 3. So 3-methyl cyclohexanol. If there is more than one substituents, the substituents are listed in alphabetical order. So what does it mean here? It means that if we have more than one group, okay, so that is, we have to arrange it in alphabetical order. Let's try for this one. We have 1, 2, 3, 4, 5, 6, 7, 8. So 8 is octanol. At carbon number 2, there is a OH group. So 2 octanol first. Okay. And at carbon number 1, 2, 3, 4, we have ethyl group. 4 ethyl, 2 octanol. And at carbon number 1, 2, 3, 4, 5, 6, 7. Carbon number 7 we have bromine. So we call it as 7 bromo 4 ethyl 2 octanol. Okay. Okay, so we'll stop at that point and we're going to continue for the next part. Okay, Assalamualaikum.